Imagine a future powered by the same energy that fuels the stars. This is the dream of fusion energy. Clean, boundless power without pollution. Fusion isn't just energy, it's a vision for a new civilization. No more desperate scrambles for fossil fuels. Clean energy could empower communities and lift billions out of poverty. The quest for fusion is monumental, with implications that reach far beyond energy. We are explorers, problem solvers, and dreamers, always reaching for the stars. The pursuit of fusion is a testament to our curiosity and our ability to collaborate globally. Scientists have chased this stellar fire for decades, inspired by its transformative potential. Now, that dream is inching closer to reality. Imagine a planet healing from centuries of industrial impact. The conflicts over resources could fade into history. Fusion energy could illuminate a path to a more equitable and sustainable existence. It's about building a brighter tomorrow. Each breakthrough brings us closer to harnessing the power of the stars. The dream of fusion is no longer science fiction, it's a challenge we are determined to meet. The future could be powered by stars. Fusion is the process that powers our sun and every star in the universe. At its core, fusion is about forcing light atomic nuclei, like hydrogen isotopes, together under immense heat and pressure. When deuterium and tritium fuse, they form helium and release enormous energy. Unlike burning fossil fuels, fusion produces no greenhouse gases. Unlike nuclear fission, it doesn't create long-lived radioactive waste. The main byproduct is harmless helium. Fusion fuel is abundant. Deuterium from seawater, tritium bred from lithium. There's enough deuterium in the oceans to power humanity for millions of years. Fusion reactors can even create their own tritium, closing the fuel cycle. Imagine a power source whose fuel is virtually inexhaustible and sourced from the oceans. Fusion's energy yield is immense. A small amount of fuel could power a city. The process is inherently safe. If conditions aren't perfect, the reaction simply stops. No meltdown, no catastrophic radiation release. Fusion's safety and abundance make it a compelling solution for our energy needs. It's a fundamentally different, cleaner path forward. The promise of fusion is a world powered by the same process that lights the stars. It's a dream that could transform our planet. Fusion is the cleanest energy dream we've ever had, and it's closer than ever before. How do we create fusion on Earth? By replicating a tiny piece of the sun's core. This means heating hydrogen fuel to over 150 million degrees Celsius, hotter than the sun itself. No material can withstand this heat, so scientists use a magnetic bottle, the tokamak. The tokamak is a giant hollow donut-shaped chamber surrounded by powerful superconducting magnets. Inside, hydrogen fuel is heated until it becomes plasma, the fourth state of matter. The plasma is held in place by magnetic fields, never touching the chamber walls. This invisible magnetic grip keeps the plasma stable and confined. Maintaining this superheated plasma is a delicate dance of physics and engineering. Tiny fluctuations can destabilize the plasma, so scientists use advanced control systems to keep it steady. Tokamaks have been built and tested worldwide, each one teaching us more about plasma behavior. The challenge is immense, but progress is steady. We're learning to sustain these miniature suns, not with gravity, but with magnetism. The tokamak is a marvel of modern science and a symbol of human ingenuity. Each experiment refines our understanding and brings us closer to practical fusion. The journey is difficult, but the rewards are extraordinary. We are mastering the art of containing a star. The future of energy may be shaped inside these magnetic chambers. Fusion's promise is taking shape, one plasma pulse at a time. Creating a star on Earth isn't easy. The main challenge is achieving net energy gain. This means getting more energy out of fusion than we put in a milestone called ignition. For decades, experiments have come close, but the tipping point remains just out of reach. Achieving and maintaining the extreme temperatures and stability needed is a monumental task. Powerful microwaves, radio waves, and particle beams heat the plasma to 150 million degrees. The plasma is wild and unpredictable, requiring constant monitoring and control. The reactor's inner walls face intense bombardment from high-energy neutrons. Scientists are developing advanced materials to withstand this harsh environment. Tritium, a key fuel, must be bred inside the reactor using lithium blankets. Sustaining fusion for long periods is crucial. Early experiments lasted seconds. Future reactors must run continuously. This demands robust engineering and precise control over every aspect of the reaction. Removing helium ash, the fusion byproduct, is another technical hurdle. Each challenge is a frontier of science and engineering. But every experiment brings us closer to practical fusion power. The path is difficult, but not impossible. With each breakthrough we move closer to lighting our own star. The dream of ignition is within reach. Fusion's promise is becoming reality. Why invest so much in fusion? Because it could change everything. Fusion offers an almost inexhaustible energy supply. Deuterium from seawater, lithium for tritium breeding. Unlike fossil fuels, fusion is abundant and available to all nations. It produces no greenhouse gases, making it a powerful tool against climate change. Fusion doesn't create long-lived radioactive waste, just harmless helium. Reactor components do become radioactive, but this is short-lived and manageable. Fusion could reduce global conflicts over energy resources. Energy independence would be possible for every country. Abundant, clean energy could power water desalination, industry, and even space exploration. It would support a growing population and improve living standards worldwide. Fusion isn't just about replacing old power plants, it's about unlocking new possibilities. It could transform economies, societies, and the environment. The benefits are vast and far-reaching. Fusion is a game-changer for humanity. The future could be brighter than we ever imagined. Fusion is a global quest, too big for any one nation. The flagship of this effort is ITER, the world's largest tokamak, under construction in France. 35 nations are collaborating to build this monumental experiment. ITER aims to produce 500 megawatts of fusion power from just 50 megawatts of input, a Q value of 10. It will test key technologies for future fusion power plants, from superconducting magnets to tritium breeding. ITER won't generate electricity for the grid, but it's a crucial step toward commercial fusion. Around the world, other labs and startups are racing to develop alternative designs and faster solutions. Private investment is accelerating progress, bringing new ideas and energy to the field. This mix of international collaboration, public research, and private innovation is driving rapid advances. Recent breakthroughs in magnet technology and plasma control have brought us closer than ever. The fusion community is buzzing with excitement. We are on the threshold of a new era. The dawn of fusion power may be within sight. The collective human effort is pushing the boundaries of what's possible. We are learning to build a star. The journey to fusion power has been long and challenging, but the prize is worth it. Fusion is no longer a distant dream. It's becoming a tangible reality. The challenges are real, but so is the progress. Decades of discovery and dedication have brought us to the brink of a new energy era. Imagine a future where energy is clean, abundant, and a source of prosperity for all. Fusion can help build a world with fresh air, stable climate, and fewer conflicts. Bringing the fire of the stars to Earth is one of humanity's grandest challenges. The knowledge and technology we gain will echo for generations. The next decades are critical. Projects like ITER will provide vital data. New experiments and private ventures will push the frontiers even further. We may see fusion power plants in our lifetimes. This is not science fiction. It's the cutting edge of science and engineering. The future is something we build together. Look up at the sun and imagine harnessing its power here on Earth. Support the research, engage with the science, and be part of the story. Fusion is a story of hope and human ingenuity. The bright horizon of a fusion-powered world is beckoning. Let's walk toward it with courage and wonder. Want to dive deeper into how this reactor could reshape our planet? Read the full article